Welcome everyone to Ask the Experts. I'm Tim Messagy, and today we're going to talk about SOCAMM2 and specifically the SOCAMM2 server module chipset. And to do that, I'm joined by my expert, Piero Bianco, who is Senior Director of Product Marketing for Power Management ICs here at Rambus. Welcome, Piero.
Thank you. Thank you, Tim. It's good to be here.
Great to have you. Hey, let's start high level. When we look at where AI is today, training, inference, bigger models, larger context windows, where do you think we stand as an industry?
Well, I would say the AI industry has really been making, big leaps forward. So we are seeing big advances in compute, in GPUs, accelerators, AI processors, and so on. I would say, now the limiter, more than compute, is being more and more power.
And memory plays a part there.
Yes, certainly. Yes. So basically, models are getting larger, they're getting more sophisticated. The amount of memory that they require is growing dramatically. So memory is becoming really the contributor that enables the advance of large-scale AI models and servers.
Okay, so whether we're talking about training or whether we're talking about inference, memory is a factor within that, maintaining that power budget.
Yes, yes. Memory is an important factor, and it's not just capacity, by the way. It's the capability of memory to, constantly move data. So move, the weights, activations, KV caches, and so on. And all of this movement of data requires energy. So in order to scale AI sustainably, we need to address also the issue of power consumed by memory.
Which suggests maybe a low power alternative like LPDDR could be a help.
Yes, yeah, correct. So in general, the requirements of AI for memory are a little bit different different from the ones of traditional servers. In the case of traditional servers, key aspects of memory are like low latency or advanced error correction features. And DDR has been and continues to be, the leading technology for those aspects. AI is a little bit different. In AI, people are looking primarily for high bandwidth and low energy, low power consumption. And LPDDR excels in those features.
It's got those features, but it was designed for mobile phones, right? So it's got, its use case was it's going to be very compact, battery operated device. And so now with the data center, very different environment.
Yes, yeah, LPDDR was indeed designed for phones. So it was designed for memory that would sit very close to the processor and operates at lower voltages, which allows exactly to minimize the power consumption and maximize the bandwidth of the memory.
So very low voltage, extremely short reach, but efficient signaling. That's kind of LPDDR's, LPDDR in a nutshell.
Yeah, exactly. So that's where the challenge is a little bit for servers because LPDDR has these excellent features, but in a server, it's going to be used a little bit differently from a phone. And farther away from the processor and with a little bit different requirements.
And in an AI server, we're not talking about, tens of gigabytes of capacity. We need orders of magnitude higher than that.
Yeah. Mm-hmm. So what the industry has done in the past has been to use solder down LPDDR memory in AI servers. So basically you solder memory close to the CPU that gives you low power, but it also creates other issues, other challenges.
Talk about those, if you would.
Yeah, I mean, one is certainly repairability. So if an LPDDR chip fails, well, the whole board fails. The whole board has to be replaced.
Right.
So that's a problem in data centers. It's expensive. It requires manpower to manage that. So that's a challenge. The second one, when you solder the memory down on the border, is supply chain flexibility. So,
Yeah.
if you make, a board, an AI accelerator, for example, it only comes with that memory. You don't have the flexibility to use different SKUs, different memory on the board. And third one, of course, is upgradability. You cannot upgrade the memory if it is soldered on the board.
So LPDDR's got some benefits we'd like, but it introduces other issues of, from scalability and operation.
Yes, exactly. So it solves one problem, which is, a primary efficiency and bandwidth. It's great for that, but it does create other challenges. Yes.
Which leads us to SOCAMM2, today's topic. And what we would like is the benefits of LPDDR, but in a module form factor that kind of addresses those scalability and repairability and those other issues that you raised.
Yes, exactly. That's why SOCAMM2 exists. Yes. Mhm.
So let's go ahead and define what is SOCAMM2.
Okay, so SOCAMM2 stands for Small Outline Compression Attached Memory Module. Basically, it is a JEDEC-defined memory standard that uses LPDDR5X, so low power DRAM memory, but it packages it into a small size compact module designed for server grade applications. So instead of soldering the memory on the board, the LPDDR memory is on a module, and the form factor of this module is optimized for the signaling requirements of LPDDR, for the density and the power efficiency requirements of LPDDR. So compression attached, what does that mean? It means basically that the module sits flat on the board. So the contact area between the module and the main board is the backside of the module itself. And this kind of contact allows for excellent signal integrity, which is needed by LPDDR given its low signaling voltage and requirements for signal integrity.
So Piero, what key benefits then does SOCAMM2 bring to AI server designers?
Yeah, so there are several of them. I mean, the first one, as we talked about, it's really what LPDDR brings to AI, which is high bandwidth and at the same time power efficiency. So low power consumption for a high bandwidth, and that's really LPDDR has these characteristics. The second one is modularity and serviceability. So if a memory module fails, it can be replaced without replacing the whole board. So minimize the maintenance that is needed and also optimize cost, minimize the cost of replacement. The third one is scalability. So basically, SOCAMM modules and the signal integrity, the signal
Mhm.
path of SOCAMM modules is designed so that the modules can sit a little bit farther away from the CPU. So they are designed for the dimensions of server and AI server board.
Okay.
Um, so that you can have more capacity, you can place more memory around the CPU. The fourth one is, as we said, this is a compression attached technology, so
Mm.
the memory module sits flat on top of the main board. differently from DIMMs in servers which are perpendicular to the board.
Right. Right.
So the module sitting flat allows more spacing for liquid cooling, in general for cooling, which is a challenge for AI applications. And the last one is, of course, standardization. So SOCAMM2 is defined by JEDEC. So basically, system makers, end users, they can buy memory modules that are equivalent from multiple vendors.
So you don't have to choose between low power and enterprise grade performance.
Exactly. Yeah, and all those other features like serviceability and all of that. Yes.
Okay, so let's talk specifically about Rambus. What does Rambus offer for SOCAMM2?
So Rambus provides a complete chipset for SOCAMM2 modules. And that includes power management and includes also the chip for configuration and telemetry features. So what we provide is three voltage regulators that go on the module. One is a 12 amp regulator, 12 amp output current regulator, and two are 3 amp output current regulators. So what these do is to convert the supply voltage of the module to the low voltages needed by the memory, the chips on the module, with very high energy efficiency. The other one is the SPD hub. So that provides presence detect and telemetry features. And telemetry because it integrates also a temperature sensor inside the chip.
That was great, Piero. Why should customers choose Rambus for their SOCAMM2 chipset?
Yeah, I would say because first thing, Rambus has decades of experience on high-speed memory interfaces and system level, the whole system around memories. We understand very well the signal integrity, power conversion challenges of high-speed memory, and also of memory that is designed in a compact form factor. We have a long track record of working with CPU vendors, with memory suppliers, and with the system OEMs. So we are able to optimize our solutions for the requirements of those stakeholders. Our products are designed to improve the resilience and the reliability of the systems. For example, by providing very low electrical noise, by generating very low electrical noise, and by being very resilient to noise generated by other components. And in particular for power management, we really provide best-in-class power conversion efficiency.
Excellent. Piero, that was a great overview of SOCAMM2 and the Rambus SOCAMM2 chipset and its benefits. Thank you, sir.
Thank you, Tim. Great conversation.
Great. And everyone, thank you for joining us. We'll see you again real soon back here on Ask the Experts.